Hey everyone, welcome to the fourth video, and this is the very last video in the reactions of chapter 11. Okay, so uh, this reaction that we're going to talk about here is also going to be talked about in chapter 14. So I'm just going to make one video on it because it's the same reaction, right? So this is Williamson ether synthesis. All right, Williamson ether synthesis. So obviously this is how we make ethers. All right, Williamson ether synthesis. Okay. So like I said, this is forming ethers, okay? And the way that we do this is we use alkyl halides and we use a strong base to deprotonate an alcohol, okay? So what this is going to look like is we take some alcohol like this and we put in NaH. This is sodium hydride. This is a strong base, okay? All this does is it deprotonates the alcohol. So if I deprotonate that alcohol, well, then now I've made this alkoxide, right? I made this alkoxide. So now if I take this alkoxide and I put in an alkyl halide like CH3Br, well, then it can do SN2 on that, right? So now all I'm doing is adding CH3 to this oxygen, all right? So that's it, right? And this works with basically any alcohol or any alkyl halide, okay? So typically, well, we'll get to that in a second. We'll do a couple of other examples. So if we take something like this, so we take this alcohol here, and as a first step we throw in NaH, and then as a second step we throw in this ethyl iodide. So to simplify this, if I see NaH and I see something like this as a second step, then I know that I'm going to be adding these carbons onto the oxygen. So all we do is say how many carbons are in this. There's 1, 2. I'm just going to add those 2 carbons to this oxygen and I'm done. So let's do that. 1, 2. That's it. Okay, that's the entire reaction. So let's take a look at one more here just to kind of hammer it home. So again, here I have 1, 2, 3, 4 carbons. So I'm going to add those 4 carbons onto the oxygen. So 1, 2, 3, 4. So that's it. Okay. So this is my Williamson ether synthesis. All right. And it just follows SN2. Just goes by an SN2 mechanism, right? Okay. So there's 2 things that I want to mention with this. Okay. So let's kind of go over and then we'll mention these 2 things. So the first thing is that let's say that I'm trying to make this ether. I'm trying to make tert-butyl methyl ether, okay? So there's 2, you can imagine there's 2 ways I could do this, right? There's one way would be that I take tert-butanol and I deprotonate it with NaH and I add in CH3Br or CH3I or CH3Cl, right? And so now I'm just going to be adding the CH3 group to this O. Well, what does that look like? Well, I just add a methyl to the O, and that's made this, right? No problem. But the other way I could do it would be that I start with this alkyl halide, right? Well, sorry. I start with methanol, excuse me. And then as a first step, I deprotonate methanol. And then as a second step, I add in this alkyl halide. Again, you would think that this would make the same thing, right? It would make this. but it doesn't. This does not work. Okay. So why is that? Well, if you remember from whenever we talked about SN1 and SN2, 3°, this is a 3° alkyl halide, right? This is 3°. 3° sucks whenever it comes to using 3° for SN2. 3° is not good for SN2. So this methanol, after I deprotonate it, that methoxide, right, this O minus here, it can't get in because it has to attack from behind, right? So it has to attack from behind on this. It how can it get in there? It can't get back there because there's 3 methyl groups that are blocking its path, right? So this reaction can't happen. So this does not work. So the only way that I can do this is that if I use this deprotonated, and then this is a methyl bromide is fantastic for SN2, right? So now this is going to do SN2 on that. So what I'm trying to get across is that whenever you're doing Williamson ether synthesis, you have to be careful of what's the nucleophile and what are you attacking, because some cases it works both ways. But in this case, if I use this is the alcohol versus this is the alcohol, only one actually works. So this one is good and this one is not. Okay. So you had to be careful with that, right? So as a rule of thumb, you want to make sure that this alkyl halide is as least substituted as it could possibly be, right? That's basically what we want to do. We want to make sure that the substitution on the alkyl halide is as low as possible. Okay. Okay, so we've mentioned that. Let me get rid of this, and then we'll talk about one other important thing whenever it comes to Williamson ether synthesis. Because so far we've been doing intermolecular reactions, but we can also do intramolecular reactions. So let's say that I take this, one second. Let's say I take this alcohol that also has an alkyl halide on the other side, and I throw in some base, so NaOH. What do I get? Well, turns out that I get this, which may seem a little counterintuitive. So let's think this through. So this base is going to come in and it's going to deprotonate that OH, right? And I could also use NaH here, right? It's no problem. So this base is going to come in, it's going to deprotonate this NaOH, or it's going to deprotonate this alcohol, sorry. And then that leaves me with an O minus on this side, right? And now what happens is this can actually attack itself because this is a strong nucleophile, right? And this chlorine is a good leaving group. So it's going to attack this chlorine and react with itself in an intramolecular fashion. And then what does this give me? Well, I have 1, 2, 3, 4 carbons. So 1, 2, 3, 4 carbons and an oxygen in a ring. So a 5-membered ring with an oxygen. I get this 5-membered ring. So not only can I make regular ethers between 2 different molecules, right? I can also make a cyclic ether like this. So I can make an oxyrane, I can make an oxetane, oxalane, right? There's a lot of different things that I can make by reacting linear molecules like this that have an alcohol and an alkyl halide in them at the same time. So this is a very good way of making molecules like this. Okay. So again, I can make rings or I can make regular ethers. Okay. So those are the 2 ways. So I take the alcohol, deprotonate it with a strong base, and then after that I throw in an alkyl halide and boom, that's Williamson ether synthesis. Okay. So that's really all there is to mention about Williamson ether synthesis. Again, it's going to be mentioned in chapter 14, but this is the only video that there's going to be on it because in chapter 14, it's the same thing. It's just review of that. Okay. So Hopefully this video was helpful. Thanks for sticking with me for the videos for chapter 11. We're going to do chapter 14 next. And hopefully that shouldn't be too many videos. And then we'll be into chapter 19. And then we're done with reactions for this class. So appreciate you watching, and I'll see you in the next one.